We are going to start the presentation. In our lives, there are many examples of alkanes. The first picture shows electrical power generation, and this is a water heater. These examples are all composed of methane. This is the structure of methanes and its molecular formula, CH4. Refrigerant is an alkane and mainly contains ethane. Ethane has a structural formula like this, and we call this C2H6. The bullets in paintball guns are made of propane. The structural formula of propane looks like this, and the molecular formula is C3H8. Next, an alkane is used as a fuel for cooking stoves. Also, lighter fuel is an alkane. All of these examples use the alkane called butane. The structural formula of butane is this one, and its molecular formula is C4H10. Many types of glue are mainly made of hexane. The structural formula of hexane is this, and the molecular formula is C6H14. There are many examples of alkanes. Now let's learn about what an alkane is. Alkanes are hydrocarbon compounds. They contain only carbon and hydrogen atoms. Each carbon forms 4 single bonds. The general formula for alkane is CnH2n plus 2. This means that an alkane that has a structure that holds 1 carbon atom will have 4 hydrogen atoms, 2 carbon atoms, 6 hydrogen atoms, and so on. Now let's learn how to name alkanes. There are some IUPAC rules to name alkanes. First, the root, or parent chain, of the compound is named by using the longest continuous chain of carbon atoms and applying the standard naming rules. Each carbon along the parent chain is numbered from one end of the chain to the other. Second, every branched group, called a substituent, is named by subtracting the -ane suffix and adding a -il suffix. Third, every substituent is then given a locus, a number that indicates to which carbon in the parent chain the substituent is bonded. The last one is when there are repeated substituents along the parent chain. Greek prefixes are used to designate the number of those chains found in the molecule. As seen on the screen, under the IUPAC alkane rules, we have to use the Greek prefix that indicates numbers. For example, 1 for meth, 2 for eth, and 3 for prop, and 4 for but. Now let's learn how to draw the structural, line, condensed, and molecular formula of alkanes. Here are some examples of butane. First, to draw the structural formula, you should check if it is an alkane, alkene, or alkyne. Then check the prefix. There are 4 C's and 10 H, which is butane. To draw the line formula, you just have to draw the line without letters. In a condensed formula, each carbon atom is written separately, and following each carbon atom are listed to the other atoms that are bonded to the carbon atom. Finally, to write a molecular formula, you just have to know how many C's and H's are there. Now try to name 5 different types of alkanes. In question number 1, you have to find the parent line first. There are 6 single bonded carbons, so it is going to be hexane. Then there is 1 carbon added to the third line, so it is going to be 3-methylhexane. The next question has 5 single bonded carbons, so it is going to be pentane. Then 1 carbon is added to the second line, so it is going to be 2-methylpentane. In question 3, the parent line has 6 carbons, so it is going to be hexane. Then there is 1 carbon added to the second line, and another one is added to the fourth line, so it is going to be 2 and 4-dimethylhexane. You put di in front of methyl because there are 2 methyls. Question 4, the parent line has 6 carbons, so it is also going to be hexane. Then there is 1 carbon added to the third line and 2 carbons added to the fourth line, so it is going to be 3-ethyl 4-methylhexane. Question number 5. Heptane has 7 single-bonded carbons. Question 6. Decane has 10 single-bonded carbons. Question 7. It is 2 and 2 dimethylpropane, so you have to draw 3 single-bonded carbons first, and there are 2 methyls connected to the second line, one on top and one on bottom. And question number 8. It is 4-ethyl 5-methylheptane, so draw 7 single-bonded carbons. There is an ethyl connected to the fourth line and 1 methyl connected to the fifth line. This time, let's draw the structural formula with the name. Question number 9. We have to draw 3-methylhexane. First, draw 6 carbons because it is hexane and add 1 C on the third line. So it would be 3-methylhexane. And question number 10. It is 4-ethyl 2 and 4-dimethylhexane. Draw single-bonded carbons because it is hexane and add 1 methyl on the second line and another one on the fourth line. Also draw 1 ethyl on the fourth line. Now let's solve the practice questions. In question number 1, the parent line has 3 Cs and 1 branch carbon is connected to the second line. Therefore, it is going to be 2-methylpropane. Question number 2. The parent line has 4 Cs and there is 1 carbon on the second and third lines connected to the parent line carbon. Then it is 2,3-dimethylbutane. On question number 3, there are 4 Cs as a parent line and 1 bromine connected to the second line and 1 carbon added to the third line. Then it is going to be 2-bromo-3-methylbutane. Question number 4, there are 5 Cs as a parent line and it has 1 branch line on the fourth line and 1 chlorine on the first line. Then it is going to be 1-chloro-2-methylpentane. Question number 5. There are 8 Cs as a parent line and 1 iodine is added to the first line and 1 ethyl is added on the fourth line and 1 iodine is added on the fifth line. Therefore, it is going to be 4-ethyl 1,5-diiodooctane. Let's solve the questions of the drawing alkanes. In question number 6, it says 2-bromo-2-methylbutane. First, you can draw the parent line, butane. Then connect 1 bromide on the second line and 1 carbon on the other side. In question number 7, draw the pentane, which is 5 single-bonded carbons, and add the ethyl, which is 2 branched carbons on the third parent line. Question number 8, draw the butane, which is 4 single-bonded carbons, and draw 1 branched carbon on the second parent line. Question number 9, it is an isomer of a butane that has 3 single-bonded carbons and 1 methyl on the second parent line. It is called isobutane, or could be called 2-methylpropane. Question number 10. Parent line is heptane, and there is 1 methyl on the third parent line, 1 ethyl on the fourth, and 1 ethyl on the fifth. In total, it is 3 and 4 ethyl 5-methylheptane.
Next, let's learn about isomers. Isomers are compounds with the same molecular formula, but different structures. They share identical molar masses and very similar physical properties, but have different names, characteristics, and chemical properties. This is one example of an isomer. There is butane and its isomer can be 2-methylpropane, which has the same molecular formula, which is C4H10, but has a different structure. Also, the other two examples, ethanol and pentane, have the same molecular formula with their isomers, diethyl ether and 2-methylbutane, with different structures. Now try to draw and name 2 isomers for each questions. For question 1, it is 1-bromo-2-chloropentane, and you can switch the position of chlorine with the other lines and their names would be 1-bromo-3-chloropentane, 1-bromo-4-chloropentane, or 3-bromo-2-chloropentane. For question 2, isomers of C6H14 could be written as hexane or 2-methylpentane, since they have the same molecular formula. For question 3, isomers of C4H8 can be written as but1-ene or but2-ene. The only difference is that they have different structures but have the same molecular formulas. Cycloalkanes are widely used in everyday life. Examples: motor fuel, natural gas, petroleum gas, and kerosene are examples of cyclopropane. Cyclopropane has 3 Cs and 6 Hs and looks like this. Alkenes that have a cyclical or ring-like structure are known as cycloalkanes. Like other alkanes, they are saturated compounds. All of the C bonds are single bonds. They contain one or more all-carbon rings. The general formula for a cycloalkane is CmH2n. There are no cycloalkanes of 1 or 2 carbon chains. Now let's learn about how to name them. The first one has a hexagonal shape, and there are 6 carbons bonded singularly to each other, so it is going to be cyclohexane. The molecular formula is 6,6H12. The second one has 5 Cs connected to each other singularly, so it is going to be cyclopentane, and the molecular formula would be C5H10. The last one has 4 Cs connected to each other with a single bond, so it would be cyclobutane, and then the molecular formula would be C4H8. Now let's learn about how to draw the different types of cycloalkanes. The first example has 3 carbons, and it is therefore cyclopropane. If you connect them, it is going to be triangular shape. The line formula is easy to draw because you just have to draw the shape without writing the letters. For the condensed formula, you can indicate how many hydrogens and carbons are present on each edge. For the molecular formula, write the total number of carbons and hydrogens. Cyclobutane uses the same steps of drawing the structural line condensed molecular formulas as cyclopropane. Drawing cyclopentane requires the same steps as 2 above. Try to draw the structural formula with the name, and then try to name the structural formula with the drawing too. For question 1, you have to draw methyl cyclopropane. Draw the cyclopropane first, which is a triangle, and add 1 methyl to the first point of the cyclopropane. Then it would form like this. For question 2, we are going to draw 1 and 2 diethyl cyclobutane. The parent line would be cyclobutane, which is a rectangle, and 2 ethyls are connected to the first and second points of the cyclobutane. Now try to name these structural formulas. For question 3, the structural formula is an hexagonal shape and has single bonds, so it can be cyclohexane. Secondly, we can see the CH-CH2-CH3 as propyl. Additionally, it has a methyl in the first carbon, therefore it names the 1-methylpropyl. For this example, you have to first find the parent chain, then find the branch chain. Then it is going to be 2-ethyl, 1 and 3-dimethyl cyclooctane. In everyday life, there are many uses of alkyl halides, and freon gas is one of them. It is made of chlorofluorocarbons and has 2 chlorines and 2 fluorides connected to the carbon in the center. Chloroform is also an example of alkyl halide, and it is made of trichloromethane. 3Cls and 1H is connected to the C in the middle. Degreasing agents can be used in everyday life as an alkyl halide that it is made of trisodium phosphate. There are 4 oxygens connected to the P in the center and 3 NAs around them. Here are some examples of naming alkyl halides. When you see the first example, 3 Cls and 1 hydrogen are connected to the C in the middle. It is going to be chloromethane. The second example has 1 bromide added to the second line, and 1 C is connected to the second line as well. Then it is going to be 2-bromo 2-methylpropane. Now try to name these two. First, you can see that the parent line has 5 Cs. Then it has 1 Cl connected to the first line and 1 in the second line. There is another carbon bonded on the third line. Therefore, it would be 1 and 2 dichloro-3-methylpentane. For the second one, the parent would have 3 Cs, which is going to be propane, and 1 bromine is connected on the second line. This will be 2-bromo-propane. The first one is 2 and 3 dichloro-3-methylpentane. Draw the parent line first, which is pentane, and draw the branches such as 1 chloride connected to the second line and 1 on third. Then draw 1 C on the bottom of the third line. The second one is cyclopentyl bromide. This time you should find the parental line at the beginning, which is cyclopentyl. Then there is 1 bromide bonded to an edge. Try to name them with the structural formula given. The first one has 1 bromide in place of 1 hydrogen and has 1 carbon and 3 hydrogens. Then it is called bromomethane. The second one also has bromide in place of 1H and has 2 carbons and 5 hydrogens. Therefore, it is bromoethane. Now try to name this. Try to draw structural formula with givens. Ethyl fluoride can also be written as fluoroethane. Draw the ethane, which is 2 single bonded carbons, and connect it with fluorine on the first parent line. For 3-bromo 2-chlorohexane, draw the 6 single bonded carbons first, and add 1 bromide on the third carbon and 1 chloride on the second carbon. Alkanes and alkenes are very similar. They are both hydrocarbons. However, alkenes have at least 1 carbon-carbon double bond. This means that they are unsaturated. Recall that saturation occurs when no more hydrogen atoms can be added to the compound and all carbon atoms have formed 4 bonds with other atoms. Alkenes are hydrocarbons with at least 1 double bond. The general formula of alkenes is CnH2n. Carbon-carbon bonds are either saturated or unsaturated. Saturation occurs when both carbons are each bonded to 4 atoms through single bonds. The compound holds the maximum amount of hydrogen atoms possible. A saturated compound has no double or triple bonds, only single bonds, and holds the maximum amount of hydrogen atoms possible for a given carbon chain. An unsaturated compound has at least 1 double or triple bond and holds less than the maximum amount of hydrogen atoms possible for a given carbon chain. Now try to name these. For the first example, there are 4 carbons. We can see that the first and second carbons are double bonded, so it is going to be butene. For the second one, you can see the double bond between the second and third carbons, and there are 4 carbons as a parent chain. so it is going to be butene. Try to name another one. First, check the parent line. Then check if it is single bonded, double bonded, or triple bonded. Lastly, check the branch carbon. Then it is going to be 2-methylpro-1-ene. Now try to draw structural formulas with the names given. First, check the parent line. Then check if it is single bonded, double bonded, or triple bonded. Lastly, check the branch chains. So it is going to be 4,4-dimethylhexatuene. The next one, also check the parent chain first. Then check if it is single bonded, or double bonded, or triple bonded. Then add any additional branch chain if necessary. Then it is going to be propene. Draw the structural formula with the name given. First, check the parent chain. Then check if it is single bonded, double bonded, or triple bonded, and add any branch chains if necessary. Then it is going to be 2-methylbutene. For question number 1, find the parent chain first, then find the branch chain. Then we can see the double bond between 4th and 5th carbons. So it is going to be 3 and 4 diethyl, 2 and 6 dimethyl, bucked or in. Find the parent chain first. Check if there is single bond, double bond, or triple bond. Then find the branch chains. The double bond is between 1st and 2nd carbons, and it is going to be 3-methylbutene. The next one, find the parent chain first, then find the branch chain. Then it is going to be 1-propylcyclobutene. Find the parent chain, then find the branch chains. There is double bond between 1st and 2nd carbons, and it will be dihexene. Next one, draw the parent line first, which is hexene, and there are 2 hydrogens placed opposite to each other. For the second one, the parent line is butene, which is 4 carbons, and connect methyls on the 2nd and 3rd carbons. Then it is going to be 2 and 3 dimethylbutene. For the C3-methyl-3-hexene, draw 6 carbons, 1 double bond between the 3rd and 4th carbons, and add 1 hydrogen on the 3rd carbon, 1 methyl on the 4th one. For cyclohexene, draw 6 connected carbons and put 1 double bond between the 1st and 2nd carbons. To induce the artificial ripening of fruits, ethine, which is an example of an alkyne, is mainly used. For rocket fuel, propane is mainly used. Alkynes are unsaturated hydrocarbons that contain carbon-carbon triple bond. The general formula for an alkyne is CnH2n-2. A triple bond in the molecule causes alkynes to exhibit different chemical properties than alkenes or alkenes. Alkynes tend to be very volatile, reactive, and they are very rarely form cyclic molecules. Saturated means single bond and usually straight chain and solid at room temperature. Unsaturated means more than double bond and chains band at the double bond and liquid at the temperature room. Now try to name these. Check the parent chain, then check the branch chain, and check the number of bondage. There is triple bond between 1st and 2nd carbons, so it is going to be pentyne. With the next one, it goes with the same steps. Check the parent chain, check the branch chain, check the number of bondage. There's It's gonna be 3-methylbutene. Now try this one. Find the parent chain, then find the branch chain. Check the bondage. There's a triple bond between second and third carbons, so it is gonna be 4 and 4 dimethylhexane. This time try to draw these. Draw 3 carbons first. There's no branch chain. Then draw a triple bond between the first and second carbons. For the next one, draw 9 carbons and connect 1 methyl in the fourth carbon. There must be a triple bond and double bond together because it is known and 9. There's a triple bond between the first and second carbons and a double bond between the seventh and eighth. Try to draw this. First, draw 9 carbons and add the branch chain. Check the bondage and draw a triple bond between fourth and fifth carbons. For question number 1, there are 8 carbons and a triple bond, so it is going to be octype. For question number 2, there are 5 carbons and 1 branch on the third carbon. And it is triple bonded, so it is going to be 3-methyl 1-pentyne. For question 3, there are 5 carbons, which is the parent chain, and methyls in the third and fourth carbons. Then there is a triple bond between the first and second carbons, so it is going to be 3 and 4 dimethyl 1-pentyne. For question number 4, there are 5 carbons in the parent chain, and methyls in the third carbon, one on top, one on bottom, and a triple bond between the first and second carbon, so it is going to be 3 and 3 dimethyl pentyne. For question number 5, draw 7 carbons. There is a double bond between the first and second carbons, and a triple bond between 6 and 7. There is a double bond and triple bond together. There is an en added to the name. For question number 6, draw 6 carbons and draw a triple bond between the first and second. For question number 7, draw 5 carbons because it is pent, and draw a triple bond between the second and third carbons. For question number 8, draw 2 carbons because it is F, and a triple bond between the 2 carbons. Household cleaners are one of the most widely used products that are mainly composed of alcohols. They are made of ammonium hydroxide, and the structural formula looks like this, and it is made of NH4OH. Antiseptic is another example which is made of alcohols, and more specifically, it is made of phenol. The structural formula looks like this, and the molecular formula is C6H5OH. Moreover, fossil fuels, solvents, and perfume contain alcohol. They are specifically made of ethanol. The structural formula looks like this. The molecular formula is C2H6O. An alcohol is formed from a hydrocarbon that is covalently bonded to a hydroxyl group. The general structure of an alcohol is expressed as ROH, where R represents a hydrocarbon chain or ring and OH represents at least one hydroxyl group consisting of an oxygen atom and hydrogen atom. Most alcohols dissolve in water. Alcohols have a higher boiling point than alkenes because of their ability to form hydrogen bonds. Now try to name these. For the first one, there are 3 carbons and 1 OH is bonded to the second carbon, so it is going to be propanol. For the second one, there are 3 carbons and 1 OH is bonded to the second carbon, so it is going to be propanol. Now try this one. There are 5 carbons and 1 OH connected to the second one. There is also one methyl bonded to the second carbon. So it is going to be 2-methylpentanol. This time try to draw them. For the first one, draw 4 single bonded carbons because it is but, and add 1 OH on the second carbon that it is a null. For the second one, methanol has only 1 carbon. Add 1 OH to it. This time try to draw this one. Draw the phenyl, which is a 6 carbon ring with alternating double bonds. Then attach an ethanol group to the second carbon. Then try to name them. For question number 1, 3 carbons are the parent chain and 1 OH is added to the second carbon, as is a methyl group. So it is going to be 2-methylpropanol. The ring is called benzyl and there is 1 OH added to the carbon, so it is called benzyl alcohol. For question number 3, it is phenyl because there are 6 carbons attached to each other with alternating double bonds. Then you can see 1 O and H are connected to the first carbon. For question number 4, it is ethyl alcohol because it has to be ethane, but OH replace 1 O and H are connected to the first carbon. The general formula for an aldehyde is RCOH. The terminal carbon chain is double bonded to an oxygen and single bonded to a hydrogen. In the case of methanol, R is a hydrogen atom. One of the uses of the aldehydes is to preserve dead animals, and it is mainly composed of 1,4-anhydroerythritol. Another example is benzaldehyde, that it is mainly composed of 4-benzaldehyde. Also, almond extract is another example of an aldehyde. It's made of 3-hydroxybutyl. Ketones are similar to aldehydes in that they have a carbon double bonded to an oxygen atom, but the difference is that the oxygen is attached in the middle of the chain or ring. The general formula for ketone is RCOR. Paint stripper is an example of a ketone and is mainly composed of acetic acid, also called ethanoic acid. Spearmint flavoring is another example of ketones and is made of 2-diethylamino and 2,6-dimethylphenyl acetamide. The general formula for an ether is ROR. Ethers contain an oxygen atom that is inserted in the hydrocarbon chain or ring. Ethers are more polar than alkenes, but not as polar as alcohols. They have relatively low boiling points compared to their analogous alcohols. Anesthetic is an example of ethers and mainly composed of 1-chloro-2,2-trifluoroethyl difluoromethyl. Cocaine is another example of ethers and is mainly composed of methyl 2R3S, 3-benzoloxy, 8-methyl, 8-azabiclooctane, 2-carbohydrolate. Waxes are another example of ethers and are made of ibuprofen. Amines are near relatives of ammonia. The general formula for an amine is RnR2. There can be 3 hydrocarbons attached to the nitrogen, or 1 or 2 of the R groups can be a hydrogen atom. They smell of old fish, urine, and rotting flesh. Dyes are an example of amines and are made of C37 H44 ion 3O4. Drugs are another example of amines and are made of ethinyl estradiol. The general formula for an amide is RCONR2, where one or both of the R groups on the right can be a hydrogen atom. Some uses of amides include pharmaceuticals, artificial sweeteners, and adhesives. The plastic and rubber industry make products which made of amides. For example, hexamine is often used. Pencil and inks are another example of amides and are made of ethoxylated alcohol. The general formula for carboxylic acid is RCOOH. The R group is a hydrocarbon chain or ring or a hydrogen atom. The carbon is double bonded to an oxygen and single bonded to an OH group. Vinegar is an example of a carboxylic acid and is made of acetic acid. The irritative component of bee sting is an example of carboxylic acid and is made of formic acid.